What's up, my lazy family? Welcome to another Teaching Machines chapter. In ML for Lazy World, we teach and learn as lazy. So in this video, we will learn about yet another concept of machine learning, that's polynomial regression. This video will be divided into two parts. First part will be the theory part, where we will try to understand what is behind the scenes of polynomial regression, and the second part will be the code part. So now, I know the theory, we are machine learning engineers and we want practical, but believe me, when you know the theory, you know the code. When you have the basic understanding of theory, you know what's going behind the code. So first of all, the code is very much important, but the theory is too important in order to understand what's going behind the scenes inside the tummy of that code. So let's start the theory.
Now, let's understand the theory part of polynomial regression. So, what we have to understand what polynomial regression means. I'm not going to give you the in-depth detail of what polynomial regression is, but just a small intuition so that working with polynomial regression is easy. It is not that much difficult. So suppose we have a data and we want to plot that data on x and y axis, that's in a graph. So we may get different kinds of data based on the type of data set we have. Then we were doing the linear regression, simple linear regression. What we did, we tried to find the line of best fit. So we try to find this line which is the best fit around this data, and we saw that this line approximates very perfectly. Now suppose that we have a data set that's not like this, but that's not like this, but that is like something like this, or say something like this. So how do we draw the line at this time when we have this type of data? Suppose we try to train a model, a simple linear regression model, and we come up with this line. Since it's not the best fit, and we count this line for this model, it's not best fit. So in those times, what we need to do, we need to get the polynomial regression model to be trained on these kind of models. Now the concept of polynomial regression is very simple. So how do we understand why do we need polynomial regression? Now suppose that we have this kind of data, as we are assuming that we have this kind of data. For this kind of data, you may get that the line of best fit is not this straight line, rather it's like this. For this, it's like this. So we have a quadratic, a curvature in the line of best fit. For this line, as a straight line, we had an equation y is equal to mx plus b, where we have the highest degree of polynomial equal to 1. But when we have a data that is something like this, we don't need to have the equation this simple, because this simple equation is not fitting the data very well. So what do we need at that moment is to have an equation of the line that is this, to have an equation of the line that is this. So how do we get that equation? So simply what we have different equations, polynomial equations with the different powers. So this has a power 1. We have an equation that's y is equal to ax squared plus bx plus c. We have an equation, as cubic equation, ax cubed plus bx squared plus cx plus d. So this is quadratic equation. This is cubic equation. So we have different types of equations for different purposes. And this type of line, this type of equation gives this line. This type of equation gives maybe something like this line. So we have different equations for different lines. Now we need to try to understand which line is best for our data. So suppose for this data, for this kind of data, we may be having a quadratic line. We may be having a cubic line. So it's up to us. So for that purpose, we need to generate a polynomial regression model. So polynomial regression model. This model will try to fit the data that is something like this. that is something like this. So these kinds of data will be fitted by this polynomial regression. We don't need a polynomial regression model. We just need a regression model which has the polynomial features. So we need to generate the polynomial features first. Then we need to train the model, same model that was in linear regression, and then we need to predict. All we need to do is to get those features. So what features do we need? Suppose if we have x as 1, 2 and 3. Then if we are talking about quadratic equation, that's quadratic equation, so we will be having the polynomial features of 1 square, 2 square, 3 square, like this. But when we will talk about this equation, this polynomial feature, since we have ax square plus bx plus c, so we will be having for every one data point we will be having 3 points. So for first data point we will be having 1 square, 1 cube, and for second we will be having 2. Sorry, we're not talking about cubic equations, we're talking about quadratic equations. So we will be having 1 and 1 square. We will be having 1 and 1 square. We will be having 1, 2 and 2 square. We will be having 1, 3 and 3 square. This is the constant, that is this c, and these are for this. So if we can see that here for c there is x, and the value of x is 1, 1, 1, that makes it c. Else it could have been 2c, 3c, but we have 1c, and here we have bx, that is b2 for 2, and for here we have a 2 square. So these are the things, these are the constants, these are the features, these are the numbers we need to get in order to train the polynomial regression model. These are the features that will be given to the regression model so that it will predict, or it will try to get a line that fits this data, that fits this data. So in this way we need to get the polynomial features.